Hi guys, for today's lesson we're going to be dealing with differentiation with negative powers. Okay, so when you're asked to differentiate functions with a single term denominator involving x, we can convert the expression to index form with negative powers. So in the past, like in previous sort of lessons, we haven't dealt with when our x is on the denominator. And if we have a denominator which is a single term and it involves x, we can pretty much convert this x to no longer be a denominator, but just have some sort of negative power. And this is something that we're able to differentiate using the rules that we've learned so far. So that's pretty much involving this power going out the front and this power going down by 1. So for example, if we've got f of x equals 5 over x, that's the same as 5x to the power of negative 1, because that x was pushed down the bottom by that negative 1 power. And when we differentiate this, the negative 1, we can pretty much ignore that 5. That 5 can just stay put. This negative 1 can come to the front, and that negative 1 has got to go down by 1 to a negative 2. The 5 and the negative 1 are going to multiply to give negative 5, and we're going to get x to the power of negative 2. That means x is down the bottom to a power of 2. So that is going to be your derivative. Next up, if we've got this, notice that we've got x on the denominator, and this is just a single term. We can pretty much ignore the 1 over 5, so that can come to the front as a constant, which is not going to affect the derivative. And then we've got x to the power of negative 3, because x to the power of 3 was pushed down the bottom. And that means our derivative, dy dx, we're using this notation instead, which is okay. That negative 3 is going to come to the front, as you can see there. And the negative 3 becomes a negative 4, goes down by 1. The 1/5 and the negative 3 can multiply to give negative 3/5. And the x to the power of negative 4 is going to go down the bottom. That can pretty much go down the bottom with this 5. So it's going to be negative 3 over 5 x to the power of 4. Okay, let's do some harder examples. So differentiate this. Again, we can see here that we've got our x as a single term down the bottom of this fraction. So we can kind of apply a few ways to do this sort of function, find the derivative of it. So the strategy is to convert the single term denominator to its negative index form. So this x to the power of 2, well, we can pretty much pull that out the front. We can pretty much multiply it by that fraction. So we're taking that as one part, and then we're taking this denominator as like another section. We're kind of splitting up this fraction into two parts. This part here, its negative index form is x to the power of negative 2, which is multiplying by this this bracket. We can expand these brackets. That just multiplies each thing. And when we're timesing powers of x, you've got to remember to add the powers. So negative 2 plus 4, that's going to give a power of 2, and that 5 is going to just stay at the front. 2 plus negative 2 gets x to the power of 0, and x to the power of minus 2 times 3, well, that's just 3 lots of x to the power of minus 2. This is something that we can definitely use our typical differentiation rule for. So this part's going to make 10x. The derivative of 1, which is the same as x to the power of 0, that's just going to give you 0. And this, the negative 2 multiplies with the 3 to give you negative 6, and x to the power of minus 3. And this term here, the x to the power of minus 3 can go down the bottom of the denominator, and you get this as your final derivative, f dash of x. Okay, next up, consider this function here. Each of these parts just has x as a single term, so we can deal with this. This is okay. We just make sure we want to deal with each of these parts separately. So first up, we want to find the derivative, find dy dx. We want to convert both of these to negative index form. So that's 16x to the power of minus 3, and take away 24x to the minus 2. Doing our usual methods, we get this, because minus 3 times the 16 gives us minus 48. And next, the minus 2 times the negative 24, that gives us positive 48 there. And we want to get rid of those negative powers and put our x's on the denominator once again. So that's our derivative right there. Next, we want to write that derivative as a single fraction. We want to combine these two fractions to make one fraction. That we have to add these together, so we make a lowest common denominator between these two. The idea is we want to make these denominators the same. So if we multiply top and bottom of this one by x, that will allow us to have a denominator of x to the power of 4. That's going to be our lowest common denominator. So we get minus 48 plus 48x. That's going to be up on the top. And x to the power of 4 is going to be our denominator. So that is our derivative as a single fraction. That's a really common sort of trick or step you need to do to be able to work with these derivatives. We like one fraction rather than two. This is a little bit harder to work with rather than this. Question C, find the point on the curve. So the curve being the original function, this is our original function, that curve, where the gradient is 0. So because we want to know where the gradient equals 0, that means we have to deal with the derivative. This is all about gradient, and we want our gradient to become 0. So because this is the gradient that we just found as a single fraction, this is a lot nicer to deal with. We want this to be equal to 0. And the way to do this is just look at your numerator, because we could just multiply both sides by x to the power of 4 and it stays 0. So we just want to know when this part equals 0. You can pretty much just forget about your denominator. So when does this equal 0? That's a nice easy equation. So we end up with x being equal to 1. So when x equals 1, the gradient is definitely 0. Now we want to figure out the point. So the whole point, we know the x coordinate, but we don't know the y coordinate. We want to substitute that x coordinate of 1 into the original function. So this is the original function. It's not the derivative. It's the normal f of x function. And we want to change our x to a 1. And we get 16 over 1 cubed minus 24 over 1 cubed. That's equal to 16, take away 24, because the denominator of 1 doesn't really do anything. And we get negative 8 for our value of y. That's our y coordinate. So therefore, at this point, 1, negative 8, the gradient is equal to 0, i.e. you get a horizontal tangent. So pretty much the gradient is flat at that point. Hope this helps with the questions. Good luck.